now, and everything what you say will be actually on this recording for later review for those who couldn't come here, or if you want to come here or revisit the what did I tell you on the video. Anyways, by the way, the uploading the video will take some time, so after this session, when I start the upload, it might be evening before it's available on the internet. But anyways, today we have a couple of topics. First, I promised the programming tips, and then actually the I will be answering the questions and answers, especially for exercise 3. But before going those, there is one good question. Is it possible that there is no email confirmation when returning exercises? Yes, it is very possible. I haven't tested that yet. I will mark it to my... I'm just trusting these systems so that if I click a box that says send email confirmation, then you would also get those. But anyways, I will check that later from the return form, that is. Another thing actually before going to those big topics is please share these, especially main.c, when you are sharing it with me or anyone with the link. Please share it also, especially with your fellow students on the same group, since then you would be actually getting the same comments to all of you at the same time, not just to the one who is the owner of that the main.c on the commentable form. Okay, and there's also a question on exercise 4, but I will be taking that one later. All right, so programming tips. I promised some programming tips, and let me first start. Since speaking about programming is kind of like what? Watching other people fishing. It's nice, but you don't get the feeling. So what I will be showing you actually how I would be using the how I would be starting programming overall when I'm talking about embedded systems programming. So first of all, I will start my tool set, and then let me just create a quick project from scratch. Target device, empty schematic there. Let's see. Projects, design course. Maybe the real, oh, not that's just fine for now. This is an example of how I start my designs. Okay, there we go. Empty design starts from this design sheet. I will just add there some input and output. Digital input pin here, and also I'll just add a digital output pin. There we go, and then input pin will be my push button, and there we actually no hardware connection, and I think we used to have the pull resistor there. Apply, I just call this one for fun button. Okay, just apply, then done it, and then the output pin also software controls strong right, and this is my blue LED. Apply that one, and then let me go and take the pins button is on 2.2. Was it 2.2? Well, let it 2.1, so it must be 2.2. So that one is 2.1, and then we have the 2.2. There we go. That's the status for the hardware side. And next, wait for a while. I want to get rid of this error message here. Building is still, or actually the generating the application code, it is still going on. But okay, I will start. So practically I will start with the author statement. Something like that, and then a short description stating maybe just some programming tips. Okay, good comments already. This system actually gives you good comments. So this comment here, enable global interrupts. If you are using any interrupts, enable them on the beginning. Okay, another thing, save this top of this main actually for the variables. So variables go there. I don't like the variables in the embedded in code itself. Although it on standard C you can do it, but it's not a good habit. Okay, initial session startup, that one things, yes, excellent. And there's even nice actually you could actually here there have a function init all, your own function, and function prototype. So this is what I do. A separate function to initialize the modules, or those are called components, yes. There, and of course then you need to have the code void init all void there, and maybe just also void here. Good. And a good habit again, when you have a some functions code, you might actually also add a comment of what this the parenthesis is actually for. It's for closing this code segment. Same for the main. So main code segment is there, then another okay for loop ending there. Good. So that kind of that way you can actually keep the clarity on the code. And for what reason? Well, if you need to visit the code again, say 3 weeks from now, it's easier for you to find out what did you do. And remember, in 3 weeks, I think you are already worked on the exercise 5. You will be starting on your project work, how to make your project. Well, you need to remember what you did earlier. So basically that one help you maybe finding some working code already from the previous exercises, and then just put those on your project work. Okay, And of course then maybe say something about those functions. Init all initializes everything just for fun, something like that. Okay, the comments, I'm asking actually you to comment the code. Please keep commenting your code for your own sake. You cannot have enough of commenting on the code. I haven't seen that happening yet. And it's for you, not for me. I like to basically give comments on comments, but anyways, it's for you, so you remember what you did. Okay, good. So practically now, next, what to do with comments. So basically, I can build first the program without coding anything, meaning that I will just write some kind of pseudo code as just common text here, just basically to have a clear structure of the program. What does it do? So I have a push button and I have a LED, so maybe I can actually just make the code so that it blinks the LED. Does it sound familiar? As long as I press the button, and when I release the button it just clears that one. So what I can do instead of that, I will go to this application code part and start writing, for example, the commands like check if the button is pressed, or if the button is pressed, then keep blinking the LED, otherwise otherwise turn LED off. Okay, this is very simple exercise, but well, to keep it short, to give you the idea that okay, you basically first design the program and then start coding. I noticed actually some of these problems on the some returns, although having basically at the end the almost all programs what I have this far checked have been just perfect, but that they are functioning as they should be, let's put it this way. But I can also see that there are some, say, confusion, something like that, or some extra effort due to the fact that you are too eager to start coding instead of thinking the structure of the program. So do the program design first, and then you start doing this coding. So practically now it would be easy just to put here if button read gives 0, like that, because that was the button read. Actually it's just grounding the pin, meaning it's low active. Actually then you would check it like that, but anyways, the professionals are bragging that you can do it also by like this. So 0 is false and anything else is true. So basically if you put not button read, then that actually tests if this button is pressed or not. And then keep blinking the LED. blinking basically means that you will blue LED, you write to blue LED the opposite value of the read value. Opposite value meaning either not, or actually I think this would work also, bitwise not. Either or, actually this is just fine since it's a Boolean operator. Okay, that will change the state to opposite, but then in you probably also want to see the blink. Now it will be blinking something like 12 megahertz or something like that. It's a little bit fast for me. So then you need the CY delay function, 500 milliseconds delay. So basically this would keep the LED turning on and off at say 5 milliseconds in between, and here otherwise meaning else turn LED off, be LED write state 0. There. Ha. And again, actually here saying which parenthesis is for which if. Okay, good. That might actually have even some chances to work. Let's see. Compiling. Programming, and wow, it works. I can do my own exercises. Still, I'm not totally senile yet. All right. I hope you will hear anything, since sometimes my internet actually goes slow and I get message here that the internet is stable. So if you are getting problem of hearing my voice or seeing, it's probably on my end. I'm living on countryside and I do not have a fiber optic connection. And yes, so good. So that was one of the tricks. The next trick actually is more like a reminder on the data types on embedded systems. So for example, if you are putting a variable here, which I didn't have anything, so value, or actually let's put it here like this, 8-bit integer value val, and initialize it to 0. On embedded systems, it's a good idea to initialize the variables to some value, just for fun. So basically here I could have also the val plus plus, and now it's actually counting blinks here, number of blinks, 8-bit integer. Let me do something like that. I will show you then something. Another thing that I actually noticed on the returns, on the exercises, is that you are not necessarily familiar with the debugging code. This IDE actually comes with a pretty good debugging system. So instead of programming the device, you will click the debug or F5. There we go. Device was successfully. Oh no, there it goes. It now changes the view a bit. This yellow line actually here just shows that okay, now we are at the beginning of main. If I click the resume execution, actually it starts going, running. There we go, it runs, and now I can actually start looking at local variables. So if I click push the button and pause the code. Okay, value optimize. Optimization routines took this one out. Oh, great. Let me put a couple of breakpoints here. So usually actually you will see this value changing here, but for some reason now it's actually it has optimized that value out, so probably because it's not okay, so it's not used anywhere except just adding it. It probably the optimization then actually took it out. Otherwise, if you have a value, for example, which was also printed out somewhere, then basically you would see that value here. One way actually is I start using it. Now it shouldn't be optimized out. The funny thing about the embedded systems is actually the compilers. If you are making a optimized compiling, then the compiler decides if some variables are actually only register values, temporary register values, or in that case it probably just took the value out. Okay, now I can try running. No, it still said it's oops, sorry. Yeah, I know. Let me put it again. Now I have breakpoint inside of the if. So basically if I start running this, run, and then press the button, there we go. Currently on this it's actually 1, and why it's not changing, oh, it's stopped there. Okay, so basically then you resume the operation, and next time it comes here it will be 2. So the breakpoint actually happens before the execution of that line. But this way you can take a look how the variables are changing, or in the case of interrupts you can actually go and check if the interrupts are working and what inside of the interrupt service routine actually what happens there. So it's quite simple operation when you're using a debugging instead of just running the program. Okay, let me stop that one. The next small thing about variables, if I had a variable here, for example like that, that will be global variable within the whole file. Okay, so this shows up this file. So now I could actually here have the for example gvar. That's just fine. It shows up here but not anywhere else. You can access only within this file, or actually the this code segment and inner code segments. Just like this value here can be seen only within these parentheses with this code segment. If you had a variable inside of this for loop, I do not recommend it though, then basically it would show up only in here. Except actually on embedded systems, sometimes you would define a variable extern. Okay, that means that this variable does not actually physically belong here, but it's actually defined somewhere else. For example, on some other, for example, it could be in some header files like project.h, which is not there, of course. But anyways, the extern means that that is defined somewhere else. Extern eval cannot be initialized actually. Oops, sorry. Extern Int8 eval. No initialization, since this is just a mnemonic, meaning a link to that real value. Defined somewhere else. Okay. Third one, which, well, this extern is anywhere in the C program. It's used anywhere. When you make modular code, sometimes you need to do it that way. Although those extern variables are mostly just inside of some of these header files. One special thing for embedded systems or real-time operation systems or such is volatile. Okay, this is a real variable, but volatiles means that the, well, sorry, not uint but uint8 or 16, whatever. And these are used on flags and semaphores. So basically, inside of the program you have some flags that say, okay, one process is still going and do not start the next one. Especially when you have multiple interrupts. How you can make sure that an interrupt code on one interrupt service does not have a bad side effect on the other interrupt service code. There you basically need some flags to provide signaling inside of this inside of the code. So for those flags that are used to provide that information, basically you should declare those as volatile, meaning that for the compiler it means that it does not do any funny stuff for that one. For example, for saving some code space. Compilers, if you have one variable which is used in multiple times within the same code segment, that actually the compiler most probably will compile it such that it takes the copy of this variable to register and then uses the register value on the following commands. But if that variable is such that you should allow it to change in between, meaning, for example, a port value, reading a port value multiple times, you really want to read the real port value, not the copy of that port value on the register. So for that reason you should declare that kind of the variables which are used to save, say, information that can change somewhere else on the code or by the hardware, you should declare those as volatile type of variables. Otherwise, you can have, say, very strange behavior of the program, and this is very hard actually to find the problem. That is just this declaration. Okay, volatile. Basically, it means that it's the value can change. Value. Basically at any time. Good. So that kind of hints for the variables. So global variables, external variables, which are defined on somewhere else, on somewhere actually else in different file. There. And then this use of volatile. On the third exercise, you would be using multiple interrupts. And in order to prevent side effect, you also need to use flags. I think I have already mentioned those on the exercise. That task sheet. So those flags, please use volatile variables. Okay, those were the programming tips on my list. Next I will go and check if there are... yeah, there's excellent point on... Let me take this one out. Count. Debugging, back to debugging. I always used just this, sorry. Now the value is not changing. Come on. Back. Okay. Sorry, value is not changing. There. Compressing the code bit. I could put the debugging. Okay. Insert breakpoint. Can I put a breakpoint on that value? Let's see. Watch point on axis. Okay, did it add it? Watch point on axis. Okay, and then run. No, it doesn't show. Okay, there's such a hint that when you put a breakpoint to val plus plus, then you see values of it indeed increasing. Okay, again, breakpoint, resume. Yep, I think it works somehow. But anyways, take a closer look at the debugging environment. Usually it's just good to go by the line debugging, so I just put a breakpoint there. There's also this let's see. This watch point should also be adding a watch point should also show it on the value of it on read, write, or access. Strange. Okay, let's not go into that one. Then basic question. How does it work with printf and transmit buffer? What happens in the system? Good questions, very good questions. Oh, let's see, this is for everyone. So you basically it's one private. Okay, so you can see the last question by or comment by Rene. How exactly does it work with printf and transmit buffer? What happens in the system? I know that buffer has to be big enough, but what exactly happens when it is chosen not big enough? Okay, practically the strings are very dangerous on program. So if I have a string here, str, and put only say 20 value of the 20 here, and maybe just initialize it to null. That should do it. Does it? No, it doesn't. Sorry, my bad. Oh, actually, yes, it does. But I will not initialize it this time. Okay, and then you have next variable here, for example, VIP. Okay, VIP variable. Very important variable here. Initialize to 0. Okay, if you put the use, for example, on your code, you have a printf, meaning that I should also have the include stdio stdio.h. Okay, and if I include that one, then basically somewhere in the code, this is not interrupts are not needed yet, so I have that is printf. Character, my string is here, and then I put here, for example, like that. Oops, sorry. There we go. I just put print a string here and then a value. And the count of this string is, well, this is less than 20, I think. But let's add some more. Okay. If the string actually is bigger than that variable, it will be most probably written to the next variables. So that is a bad side effect. Printf is very basic this standard functions, and it does not do any checking how long this the variable is where you are trying to print it. It just copies the characters and translates that the value to the string value, and then at the end it puts the null null meaning 0 character. Okay, so practically it will be written to the next points. Usually the compiler, again, it basically reserves this memory space for variables somewhere on this program, and absolutely no guarantee that the user can destroy the next data easily by having too small buffers on for the printing the characters. So bad things will happen if the buffer is not long enough on for the strings, and you need to be really careful, especially with, for example, floating point numbers, how many decimals you add to the to your printout. So if you just let the this function library to decide how many decimals, then you may end up having a longer string that you actually have space for. Okay, so that question is now answered. Maybe I'll just okay, when I do percentage %f and then the variable, it does not print anything. Strange. Strange behavior. Have you tried G instead of F? Okay, let me see. There's a disclaimer that %f doesn't do anything. Let's see what happens. Does that %f actually go there? Or does anything? %f should be for floating point numbers. Okay, unused variable. String. What does that actually mean? Why does this I can't read this. Oh, it's not running yet. Okay, sorry. KDS just empty. Wow, %f actually doesn't do anything. That is strange. Okay, maybe. Okay, one way actually is to find the sprintf, this version sprintf datasheet. That's part of this the CMSIS package. Let's see what does %g actually does. Does it do anything either? %f doesn't do anything. or does it require actually the field codes like 2.1 or something like that? Some testing. No, G doesn't do anything either. Oops. Okay, my connection gets unstable again. Oops. Invalid thread. Okay, code was changed so much that it actually requires a new start for this one. So if you change too much code, then the older breakpoint actually it's not no, nothing happens. Okay, there's something about that sprint F that requires some investigation. So if anyone finds a solution to that one, please put it on the wait a minute, on the teams. I will try to find that after this session. Okay, you can set the heap size to 200. I found it nice video. Watch. What was the heap size? What? Okay, team. Would you elaborate a little bit? What's the? Yeah, heap size. Okay, it was for the buffers. Okay, then there's another question about exercise 4. I2C communication is it mandatory to write data before reading data, or once by initialization would be enough? Because if I write every time before reading, I get the slave address itself. Okay, you need to follow this protocol. Okay, on the exercise 4, take a look at the data sheet. Let me open the data. Oops. Sorry about that. Actually, I have some annotation probably here. Yeah, I have a nice annotation. How do I clear all drawings there? There we go. Not select. This is frustrating. Now it's mouse again. Okay, exercise 3. No, sorry, exercise 4. By the way, does anyone has questions about exercise 3? If you do, please put those on the chat board. Chat board, but exercise 3 is mostly say copy paste plus some code. It's not basically too much of problem there, I would say. But this SPI or I2C actually will give you some trouble. Hopefully, it was designed that way. Sorry. But I2C, we are using this microchip device. There is a trick when you take a look at the first bus reading diagram, write diagram, SM bus. So basically it's I2C bus compatible, but they don't want to pay the royalties, so they call it SM bus. Okay, and there's the functional description and write byte format. Okay. If you are writing 1 byte, there. Now I can on spotlight. All right, so write byte format actually start with the start the I2C bus. Then you have the address bit with write the bit on. That's 1 byte, and there you would use this I2C write byte command, and it returns acknowledgement. You should also check the acknowledgement bit, what comes back. Then you just write the second 8 bits and then third 8 bits and check the acknowledgements. If the acknowledgement is not there, then you don't have anything connected on I2C bus. Okay, and that's one way to check that you have communication running with. Communication channel is okay for this for the device. Okay, and this actually it's from start to end. So basically you need to use those I2C component, this primal functions, or whatever they are called. I think they are called like basic functions. To start the access to the I2C bus and write 3 bytes and then stop. Read is different. No, well, not that much different. You have the start command here. So you would have the I2C start. Again, you need to write the in between the start and end. You need to first write, of course, the slave address, and with read. No, sorry, write. Yes, with write on the line and then command byte. Basically, for example, the start the. Wait a minute, I don't remember what the commands are, but anyways, you basically have to have the address to that byte and with the command, and then basically you restart the bus. So basically, I think it was I2C restart command or something like that, with the following command being the 7-bit address with read bit on, waiting for acknowledgement and then reading 8 bits of data and giving not acknowledgement at the end. So basically you have to program your code accordingly. And then basically if you are just reading from it, then it's just the start conditioning and then address with read bit on, waiting for acknowledgement and then reading those 8 bits and giving not acknowledged at the end. Okay, so basically that's how you do the data transfer. Okay, I'll get the temp value I'm using to receive byte format. Yeah, so practically you need to check this one, and also let me close that one, and and then go and not that one on I2C. I2C master. Just getting that one, and oops. Just to get the datasheet, this is the easiest way. Datasheet on application programming interface. Generic functions. There is the start function, of course, to start the whole process, and then the master and multi-master functions. So basically you need to set the okay here I2C send start. That would be same as oops, not that one. Wait a minute, where did I put my Google? There. Slave actually means this S. And then there. Next would be master write byte. Write a single byte. So practically write a single byte will take place, for example, in here. Write with the byte. Single byte actually would be this command byte here, or read byte start with the write byte. That's the address, write, and then the following command. Okay. Then this also is a wait a minute, not that one, but then basically you would restart here I2C master send start, or restart the bus, and then master read byte. Basically it has this it basically would do this one. So first, of course, the address where the access, and then the reading the data. Okay. I hope that one cleared out a little bit and not confused too much. There. Okay. Okay, so basically that was these hints on that the I2C protocol. Actually, they are those videos. I made those in purpose, and actually also those older videos which I made in Tokyo course. And actually, I think there is some explanation. The problem, of course, those are very long videos. But take a look at those videos, and basically what you need to do is comparing this device datasheet to that PSoC component datasheet. How I can read UCK? I think this module actually has the. So I'm not totally wrong again. sometimes I was wrong, but then I noticed I was wrong about it. So when you are okay, let's see, send start send read byte, write byte, for example, does it okay, good. That's where you get the UCK. So if you are writing, then the PSoC is reading the observing the UCK, and basically it will be showing up as the register value. So I choose, see, for example, their last byte was knocked, for example, there. Then another place, I think you can, when you send the read byte, you can also put here the parameters, master read byte. Okay, so that one returns data value, data byte, but then you can actually, or you should put here if you want to acknowledge the transaction, or then the not acknowledge the transaction. So you can set the UCK for on read operation, and you can read the basically the returned UCK either on these write functions, or I would say guess that master status actually also gives you the okay, yes, if you get some acknowledgement or not. No, it actually does not say that one. So yeah, those read these data sheets of the functions, and there you can actually, there should be always the opportunity to either set or get the acknowledgement. Okay. Then I have problems with exercise 5. I'm working on it for more than 15 hours now. Excellent. Exercise 5. It's a really killer exercise. But for exercise 5, I would like to give some hints later on. Although I will show you quickly what I did. If you are not on the exercise 5 yet, you probably shouldn't pay too much attention. Okay, so acknowledgement. Acknowledgement, but the let me get that was the one wire. Where do I have the one wire library or protocol? Let's see, GitHub, playground. There's so many funny things. I'll go to my own one wire hinge here. There we go. Oh yeah, there. Maxim integrated application note has software. I recommend actually using that software, but with care. So there is protocol, code examples, and code examples say okay, just incorporate how to have output or input. That should be enough. No, it is not. It does not take into account the overhead for this kind of pipeline processor. So basically on pipeline processors, usually you get higher overhead on changing from one process to another. So function calls actually will take more clock cycles as in RISC processors. So which means that so replace by platform appropriate functions. Don't replace these by functions, but by either replacing the code or define those as make the defines for those basically. Okay. Then it gets easier. Then another thing, there's funny, for at least for me, funny. There's a tick delay. Pause for exactly tick number of ticks, where one tick is 0.25 microseconds. Okay, and here almost everything is, well, practically everything is multiplied by 4. Okay. What I did to get it to work, I took off this multiplied by 4 here, and then replaced that tick delay actually by just the CY delay US, which gives the delay of given the times. Okay. That helped so much that I could actually read the data, but sometimes it was corrupted. The final way of how did I get this really running is that I started to tweaking those numbers by comparing that one with the device data sheet. What does it give for the typical or minimum maximum values? This is an example code which probably runs on some processor, but in this ARM processor, which is inside of the Cypress the chip, on that ARM, those values are not correct. So basically tweaking those, replacing that function call to CY delay US function call, and then inlining these, or actually replacing wherever you have the output or input the command on the code, you basically just replace it by the appropriate that PSoC function. That would work much better. So hopefully within, say, less than 15 hours you can have the working solution. But yes, it takes longer time than the other exercises. But on the other hand, this course total is 5 credits. It's supposed to have, say some hours put into the coding. Unfortunately, today I have a little bit tight schedule, and basically I need to go to another meeting 10 minutes ago. So sorry about that. I will be back on this line. I might actually just turn off my audio so that I'm not confusing either you or the others. So I will keep the session open. You can chat with yourself, with each others, and I'll try to get back in, say, 15 or 20 minutes. Meanwhile, you could actually also take just a short break now, and then we can continue if the meeting is as fast as I anticipate. Okay, see you you in 20 minutes or so, maybe. Otherwise, thank you, and well, I'll be back in a minute.